All right, good afternoon and welcome to part 18 of the Artificial Introduction to Artificial Intelligence course. Today, we're going to be talking about agentic AI or the AI agent. And I hope you find this stimulating, and let's get started. All right, so let's begin today by defining some terms. What is an AI agent? So let's remember the framework of AI usage that we've previously discussed. So level one usage would be the LLM chatbot usage. This is where humans type or talk into an LLM and they ask it a question. We decide what to ask, when to ask, and what to do with the output. Everything starts and ends with you interacting with the LLM. Level two is the AI workflow, which we looked at in our previous lesson, just previous to this one, where a human designs a fixed sequence of steps in advance, and AI is plugged into specific nodes along that path. The path itself doesn't change. And level three is the level of the AI agent, where the AI itself decides what to do, a goal, the access to tools, figures out the workflow, which tool, in which order, whether to retry, and when it's done. An AI agent is an AI system that's set up to perceive its environment, reason about what to do next, take actions using tools, and observe the results. And it will repeat this loop until the goal is reached. So what's the difference? Well, when we ask AI to write an email, you type the prompt, AI will write the draft, but you will review it and you will end up putting it into your email program and sending it. You're in control at every step. Whereas if we were hiring an inbox assistant, we would give the assistant the goal. The assistant would read our emails, it would draft up a reply, flag the urgent ones, and learn your preferences over time. Here, the AI is going to decide the steps of that process. Let's go with an analogy with a chef. The recipe is a workflow where the steps are written out in advance, but you do the work and follow it exactly to get to the goal, which is the meal. If you have a personal chef, that's an agent where you say a very simple goal like make dinner for 8 people who love Italian food. So you give the goal and then leave the chef alone to do the job. You, the user, gave the goal, which is the meal, to the chef, which is the agent, who makes a workflow or a menu and shops for the ingredients or the data and adjusts it if something's out of stock, which is a cognitive thinking step. It figures out the order, the steps, the workflow, the decisions, the connectors. It uses kitchen items or tools. It adapts when a dish isn't working, which is a cognitive or mechanical step. It executes, it runs, and serves you the meal, the output. Let's look at the difference between an AI workflow, an AI agent, and a hybrid mix of the two. So when we ask the question, who decides the steps? In a AI workflow, the human is the designer. In advance, they set and design the steps. Whereas with an AI agent, the AI decides the steps at runtime. In a hybrid scenario, both fixed structure and the agent deciding some sub-steps would be part of that mixed procedure known as a hybrid setup. Let's ask, what about predictability? Well, with a workflow, it is very highly predictable. It's always the same output for the same input. But for an agent, it's very low predictability because it's going to be adapting and changing to the situation. Whereas with a hybrid, we're somewhere in the middle. How about handling surprises? Well, with a workflow, it can't handle surprises. It breaks if the input is unexpected in that workflow. But with an agent, it can adapt to surprises. And in the hybrid, this is again in the middle. What about the speed to create the system? Well, a workflow is a little bit faster to create. You map it up once and then it goes. Whereas with an agent, you got to slow down a little bit and make sure that everything is set up correctly and all the setup is right because the agent's going to take over after that. And let's think of a real world example. Let's say in the workflow, we're emailing, we're setting up an autoresponder to emails or a quiz grader. Well, with an agent, we could actually have a research assistant or a coding agent. And in the hybrid scenario, we could have a customer service bot or Netflix recommendations, etc. All right, let's move to the next step of this. Let's move on to examine something called the perceive, reason, act, observe, which is a very strange acronym, the PRAO loop. So the PRAO loop, perceive, reason, act, observe, is a framework architecture that's used to build autonomous AI agents, and it has 4 stages. The first being perceive, where we will receive input, a user message, a tool result, a file, sensor data. This is what will trigger the loop to begin. Then we have a reasoning step or a reasoning stage where we will decide what to do next, which tool to use, what question to ask, how to break the problem down. This is where the LLM will get to work on a cognitive stage. Then there's the act stage, where the tool will be used or it will generate an output. It will take action in the real world, like sending an email or running code or searching the web. And then finally, we have the observe stage, where we see the result of the action, where it will update the plan. It will decide, is the task done or do I need to loop again? The loop will repeat until the task is complete. This PRAO loop is the core operating cycle of the AI agent. It's how an AI agent works through a task autonomously rather than just responding to a simple prompt or a single prompt. My apologies. In the perceive stage, the AI agent will receive that input, which could be the user prompt or the tool result or a file that was given or data from an environment or, for example, an email arriving in an inbox. And this is what triggers the loop. It gives the agent something to work with. Then the reasoning step. This is where the AI's real neural network comes into play. It's going to decide what to do next, which tool to call, how to break the problem down, questions it's going to ask, whether it's done. Powered by that large language model, it's essentially the model predicting what would be the next best action given everything it knows. And then the act stage. So the AI will now take action. It might, for example, call a tool like run a web search or execute code or send out the email or rename a file. It will produce an output or do something in the real world. So without this stage, it's just left at that thinking or reasoning stage. And then the observe stage, where the AI agent will look at the result of the output. What it just did, and it will update the plan. Did the search give us useful results? Did the code run successfully? Is the task actually complete? Or do we need to loop back into the PRAO loop again and start this process over? The key is that the AI agent will decide its own next steps. And a regular chatbot will perceive your prompt, act once, and then be done. Whereas an AI agent does that PRAO and it will loop perhaps dozens of times and adapt as it comes along. This is what makes it an agent or makes it agentic. So let's look at some examples. Let's say the user asks an agent, book me the cheapest flight to Vancouver next weekend. The AI agent will act. It will search flights. It will do a web search. It's performing an action. The AI agent will see the results. It will observe those results. So it will get back the results and it will make a decision. It will notice that one airline site needs a direct fetch for a full price. So it reasons out that one of the websites needs a little more action. So it will fetch it. It will perform that action. So it made an adaptation along the way. The AI agent will then compare the prices. It will do the reasoning step. And then it will find the cheapest option. It will observe which is the cheapest. And then it will ask you, the user, to confirm, to act before booking. This is a good guardrail, okay? It basically says, a good guardrail says never make an irreversible purchase without approval first. right? This is something we're going to cover later in this presentation, but we're now putting a human in the loop. So let's look at a trace of an AI agent PRAO loop, right? So we give the agent the goal. Find 3 credible sources about climate change solutions and summarize the key ideas from each. So in the perceive stage, it will read that goal, understand that it needs 3 sources and summaries. It will reason in that stage, deciding to start with a web search, that would be a good process or a good tool to use, and that the best query that it will write up is climate change solutions, peer reviewed, 2024, etc. It will then act. It will call a web search tool. If it has access to that tool, it will act on that tool and get back the results. It will then observe. It will evaluate what came back, the sources. It will make a decision to make preference over certain ones that end in .gov or .edu. And when source one is a news blog, it doesn't think it's credible enough. So it's making some intelligent decisions. It will reason again. It will replace one of the sources. It will refine the search, make a change to it. It will adapt. And then it will act again. It will read the peer-reviewed papers. It will save the key findings to memory. It will repeat this for sources 2 and 3. It will reason through all the credible sources collected with the time to write up the summaries. And then it will act and observe at the same time, generating a 3-paragraph summary with citations. And it will notice and make the decision that the task is complete and return back to the user. All right, so now that we know what the PRAO loop is and how that's part of being a autonomous AI agent, let's look at 4 components of an AI agent. So the first thing is the goal that we've already talked about, right? This is kind of a system prompt. This is something you're going to give the machine that is the artificial intelligence. It's instructions, sometimes hidden instructions, that define who the agent is, what it's trying to do, how it should behave, what its limits are. This is written up before the user ever kind of gets forward and moves forward with their initial prompt, right? Then we have the tools section of an AI agent, which we saw a little bit in our previous presentation. These are the capabilities of the AI beyond just the LLM. What can it do? Because without tools, it's just a chatbot. It can receive text input and produce text output. But tools allow it to essentially have hands. Now it can search the web or write and execute code or access files, rename and move files around, do API calls, do emails, control your browser, and more. And then the third really important part of an AI agent is the memory component. This is giving the AI agent context. This is now giving the AI agent a memory and a brain that can go beyond one session. It's what the agent remembers. Short term is the current conversation. Long term is a database between sessions, allowing your agent to learn your preferences over time. And then the fourth is the guardrails, which we're going to talk more about. These are rules, these are limits. This is what the agent cannot do. Because without guardrails, agents can cause real harm. If you think about the tools they have access to, things like renaming files, opening and deleting files on your computer, or sending out emails in your name, if we don't send or have confirmation with this guardrail, we could be spending money. We could be deleting or losing files. So let's break it down even further. Let's start with the goal component. The first component, designing the goal for an AI agent. This is related to what we've looked at in prompt engineering. The goal is the foundation everything else is built on. The AI agent already knows who it is. It knows what it's trying to accomplish, how it should behave, and what its boundaries are. So it's going to cover things like identity, right? Who is this agent? A name, a role, a personality. So you could define that. You could say you are Aria, a customer service agent for North Star Electronics. You are professional, helpful, and concise. We could define a purpose. What is this agent really trying to do? For example, your job is to help customers to track orders, to process returns, and to answer product questions. We could define a scope. We could say what the agent is allowed to deal with and what is out of bounds. Only answer questions related to our company products. If a customer asks about competitors or unrelated topics, politely redirect them. We could define behavior rules, how the agent should handle specific situations. For example, if a customer is upset, acknowledge their frustration before offering a solution. Never argue with a customer. So if you cannot resolve an issue, escalate this to a human agent. And finally, we could define guardrails. This is what the agent is not allowed to do. For example, never issue a refund over $200 without manager approval. Goals don't just tell the agent what to do, they also tell the agent when to stop. The goal is like the job description and the employee handbook given to a new hire on their first day. So before they ever even talk to a customer, it's already told them their role, what they're responsible for, how to handle difficult situations, and what they're not allowed to do. One example in the Claude application of a Claude Pro account is something called the skill setting, which you can see a screen capture of right here. When Claude uses a skill, it first reads a file called skill.md, and that file contains detailed instructions about how to perform that task correctly, what libraries to use, what pitfalls to avoid, what the output should look like. That is the goal component in action. All right, let's look at the second component of an AI agent. What tools can an AI agent use? So let's look at, for example, web search, looking up current information, looking up facts, looking up news, looking up prices, anything on the internet. Let's talk about code execution as a tool, where we can allow an agent to write and run code to solve things like math problems or process data or even generate files. Let's talk about a tool like a file or a database tool where we can read and write documents, create Excel spreadsheets, create Word documents, email people through inboxes and outboxes, and access databases. Let's talk about APIs, CLIs, and MCPs where we can connect to external services, where we could book a flight, where we could check inventory or query large databases like a weather database. And let's talk about memory, where we can store and retrieve facts across the task or even between sessions with our agent. And at an even higher level, let's talk about how agents can also interact with other agents, where we can delegate subtasks to specialized agents, and one agent can direct many. The key is that the AI agent decides which tool to use and when to use it, making it more self-reliant or agentic. So these tools are dependent on things like AI models. Which model are you using? Which way are you using? Are you using it through a web browser interface or directly in something like an application? So again, here I'm going to show you an example of the connector setting in the Claude application of a Claude account, where you can actually see the connectors that I have connected to my Claude account and how it's connected to these essentially tools. Again, a good analogy is if the AI LLM is the brain, tools are like its hands, allowing it to act beyond the LLM itself. And I can also show you the plugin setting as well. So even more potential tools connected to that large language model to allow that agency to take place. Third component, the memory. So we've already briefly talked about this, but let's dig deeper. Memory is what allows an agent to maintain context, to learn over time, make decisions based on accumulated information rather than just what's in front of it right now. And there are 4 types of memory. The in-context memory, the short term, everything in the active conversation or the active chat, that's temporary memory. It's gone when that session ends. When that chat's over, that what it remembered is gone. It's limited by the model's context window size. When that window fills up after a long task, the agent starts losing some of those earlier parts of the conversation. Then there's external or long-term memory. This is a database outside of the model that persists between sessions. So this is often part of something like a Pro AI account, right? Where the agent can read from that long-term memory, write to it during tasks, allowing an agent to have that remembering for next time part. And facts can be saved from past conversations to get retrieved at the start of new ones. There's semantic memory or relevance-based retrieval. This is a smarter version of external memory. So remember, external is the long-term memory. So it's a smarter version of that that retrieves only what's relevant to the current task. So it's pulling out of long-term memory, but only those things that are relevant. It uses something called vector embeddings to find the closest match to what's being asked. Instead of loading everything it knows, the agent pulls out the useful pieces of memory. This is the same technology behind something we've looked at already called RAG. And then there's procedural memory. This is the how to do things memory. Not facts, but skills and processes, knowing how to structure a report, how to handle an upset customer. It's the to-do list. It's the how to validate a file. This usually lives in the system prompt rather than in a database. The key design challenge is deciding what to remember, what to forget, and what to keep private. Memory that's outdated or wrong is worse than no memory at all. And stored data raises real privacy questions as well. The fourth and final component we're going to look at is the guardrails, which we've already touched on briefly. This is the safety layer between a capable agent and a harmful agent. They exist on multiple levels simultaneously. So in the system prompt, the rules are written directly into the goal component. So we might actually write in, never send an email without user confirmation. This provides an immediate guardrail. We could also do it at the platform level, where restrictions are enforced by the infrastructure itself. So for example, the Claude app only can access certain things before the agent runs, and they can't be overwritten by some developers' instructions. And then the designs of the tools themselves. If the agent doesn't have access to a tool or doesn't have access to certain parts of a tool, then it can't use it. It can't bypass that guardrail. So if, for example, your Claude application is not allowed access to Microsoft Excel, then it's not going to use it. It's not a tool available to it. And finally, we have the human in the loop checkpoints, where we require human approval at certain steps. That itself is a guardrail, enforced by process rather than by code. So let's look at some types of guardrails. Hard limit guardrails, which are absolute, no exceptions. Like for example, never share user data, never make a purchase over $50. We can have soft limit guardrails. By default, that could be adjustable by the user. For example, always confirm before sending unless auto send is enabled. We can have scope restrictions, keeping the agent focused. For example, only answer questions about this company's products. So it provides a guardrail to see the AI's scope of what it can address. We can have confidence guardrails. What to do when uncertain. For example, after 3 failed searches, stop and tell the user rather than guessing. Writing effective guardrails is a very challenging task, and you can't predict every edge case that could come up. Guardrails might conflict with an agent's goals. For example, being helpful while still avoiding speculation. So too many restrictions reduce the usefulness of the AI agent. While prompt injection, which is prompts designed to manipulate the AI into ignoring or overriding or bypassing intended rules of behavior, can sometimes bypass the guardrails completely. So we have to watch out between too many and too few of the guardrails. All right, so before we go any further, let's dive back into the concept of the human in the loop. So what do we mean here? So the phrase human in the loop refers to the practice of keeping a human being involved in key decision points when using an AI agent and when involved in the AI agent's workflow. Rather than letting it be fully autonomous, we need to be part of that decision. It's essentially to the answer to the question, at what point does the agent need to stop and check with somebody before it continues? So a fully autonomous AI agent will run start to finish without a human in the loop. It's certainly fast, it's certainly efficient, but it's risky. One bad decision by the AI could compound every time and every loop that follows. When we have a human in the loop, now we have the agent pausing at specific guardrail checkpoints, and it waits for the human to review, approve, or redirect before it continues. So now it's going to be a little slower, not as efficient, but safer, especially for high risk tasks. And then we can also have what's called the human on the loop. So now what we have is the agent runs autonomously, but the human will monitor that process, and it can step in and intervene if something looks wrong. So the human isn't directly in the loop, but it's watching over or on the loop. And as soon as it sees something wrong, it will jump in to pause the loop that the AI agent is running. You're watching, not approving every step. So this is a middle ground between the fully autonomous and the human in the loop. So the checkpoints where we're having a human in the loop matter most are typically when we have things like before there's an irreversible action, before we send out an email that could cost us our job, or before we make an intense purchase or delete a file or post content on social media. If this is a step that can't be undone, maybe we need to put a human in the loop as a checkpoint there, as a guardrail. We can use it when confidence is low. If the agent is very uncertain about its actions, it should tell us that. It should surface that uncertainty rather than guess and proceed. We need a checkpoint when scope expands. If completing the task would require the agent to do something it wasn't originally asked to do and step outside of the scope of what its original goal was, it should be checking first. That's where human in the loop guardrail should come in. And before high cost actions, high cost meaning monetary costs, but also running expensive API calls or processing huge data sets or anything that's going to consume a significant amount of resources. This is where a human in the loop checkpoint guardrail would really be needed. So let's look at an example. We have this agent that sends out a mass email before the user realizes what was about to happen, but a guardrail was in place. Require human confirmation for any action that cannot be undone. This is a human in the loop guardrail. So this deeper question is that as agents get more reliable, how much do we loosen that need for the human in the loop? How much do we give up and let the AI become more and more agentic? Requiring human approval on every step defeats the purpose of having an agent. But too much autonomy and one bad loop can cause real damage. So the right answer depends on the stakes of the task, the reliability of your agent, and how reversible those actions could be. All right, so let's conclude today with some final thoughts on the AI agent or agentic AI. So the agentic behavior, the looping, the planning, the tools, this is handled by code frameworks that wrap around AI models. They manage the PRAO loop. They maintain state and they handle errors. So here you can see a chart with some popular ones right now. LangGraph or LangChain. This is a complex stateful workflow and customizable logic. Crew AI is a multi-agent collaboration where agents can act as a team. AutoGen is from Microsoft. It's a framework for sophisticated multi-agent orchestration. And then we have Vercel AI SDK, software development kit, which is a front-end focused rapid prototyping for web applications. And Mastra, a TypeScript native built for software developers needing all-in-one primitives. But if you don't want to build an AI agent from scratch, or you don't have a sort of a coding background or a development background, there are also several platforms that provide a visual interface to build and deploy. So perhaps one of the most popular, N8N, is a workflow automation tool with drag and drop nodes that will build agentic loops with an LLM in the loop and hundreds of potential integrations. There's Copilot Studio built into Microsoft, which is designed for building agents that integrate deeply within that Microsoft 365 ecosystem. There's Relevance AI, which is a low-code platform for building and deploying multi-agent workflows. And there's Zapier, which offers no code AI agent building that connects easily to existing business tools. AI agents are a much more complicated topic than we can go into this introductory course. And many aspects need to be explored when you have something like a paid AI account, which is not something this course requires of you. But AI agents are important to know about, and they can be explored in more detail in the future and specifically in your future. So, we also need to be aware of the failures of agentic AI. For example, the hallucination chain, where agents invent a fact in the loop, and then a second loop uses that hallucination as real input. And by the fifth loop, the output is entirely fabricated, but certainly sounds authoritative. So the fix requires some source citations. Build in a guardrail that's a verification step. There's the infinite loop problem. For those who've taken computer science, you know this problem, where the agent will search for info, find nothing useful, search again, slightly different terms, find nothing useful, keep looping and looping indefinitely or infinitely, consuming time, consuming money. So the fix for that, set a hard limit on how many iterations and build in a guardrail to report to the user if that limit is hit. There's scope creep, where an agent is asked to draft an email but decides on its own to also search the recipient's LinkedIn profile and its job history and will add all kinds of personal details. So the fix for that, a guardrail, strict tool permissions. Only give agents what they need for specific tasks. Do not let them go outside their scope. And finally, the irreversible action. For example, an agent sends a mass email or deletes all your files or places an expensive order before the user realizes that that was about to happen. So the fix, a guardrail, human on the loop, human in the loop. Require that human confirmation before any action that cannot be undone. AI agents make us consider things like ethics and accountability. We're going to study these in a lot more detail in the final unit of this course. So if an AI agent makes a mistake that costs someone money, who's responsible for that? Is it the user? They gave the goal, they granted the permissions, but did they really understand what that agent was going to do or what it could do? Is it the developer? They wrote the system prompt, they chose the guardrails. Did they anticipate every potential failure mode? Is it the company itself? They deployed the agent to the public. Did they test it adequately? What warnings did they give about the agent's usage? Or is the fault of the AI? Can a system with no intentions, no consciousness, actually be responsible? What does responsibility even mean in an era of AI? So these are big ethics questions that we need to consider and about things like accountability. The real answer is there is no set answer. It depends. And things like laws haven't caught up yet. Well, thank you, everybody. I hope you found that useful, and I hope you have yourselves a great day.